question that we're looking at is question 3 of paper 2005 summer 9702. A part says define specific latent heat of fusion. So we will simply write it is the amount of heat energy required to change the state of an object of mass 1 kilogram from solid to liquid or vice versa without a change in temperature. Done with this, then we have the B part, which says a mass of 24 gram of ice at minus 15 degrees Celsius is taken from a freezer and placed in a beaker containing 200 gram of water at 28 degrees Celsius. Data for ice. So they have given us a specific heat capacity and they have given us a specific latent heat of fusion as well. I part says calculate the quantity of thermal energy required to convert the ice at minus 15 degrees Celsius to water at 0 degrees Celsius. Now, one important thing that is very important when you're solving questions of thermal physics, that is when there is a change in temperature, that is always related to the specific heat capacity, which is Q is equals to mc delta theta. And when it's about change in state, like it's converting from solid to liquid, then it is about the specific latent heat, which can be specific latent heat of fusion or specific latent heat of vaporization. Now, having said that, it says calculate the quantity of thermal energy required to convert the ice at minus 15 to water at 0. So to make it simple for us, we can say that initially we had minus 15 degrees Celsius ice, and then it converted into 0 degrees Celsius ice, and then it converted into 0 degrees Celsius water. Now we know that in this part we had minus 15 degree ice to 0 degree ice. We can see there's a change in temperature, so we have to go for specific heat capacity, which is going to be Q is equals to mc delta T. Now when you look at this, you have 0 degree ice and then 0 degree Celsius water. There is no change in temperature, but there is a change in state. So when there's a change in state, we have to use specific latent heat, and here we are using specific latent heat of fusion, so that has to be E is equals to N into L. Now simply all you have to do is you just have to plug in the value because you're asking for the thermal energy. So we know that initially the mass of ice taken is 24 grams, which is 0.024 kilograms, into the specific heat capacity of ice, which is 2.1 into 10 raised to the power 3. So you will write 2.1 into 10 raised to the power 3 into delta T. That has to be, it went from minus 15 to 0, so that the change in temperature is 15 degrees Celsius. You're not supposed to convert it into kelvins because a change in temperature is always in degrees Celsius. And then we're just going to add this as well. So the mass that we have from ice to water to 0.024 kilograms into the specific latent heat of fusion of ice, which is 3.3 into 10 raised to the power 5. Having written that, what you're going to plug this in calculator. 0.024 into 2.1 into 10 raised to the power 3. And you get 8,676, which you can write as 8,700 joules. 8,700 joules. And this is it for first part. The second part says, assuming that the beaker has negligible mass, calculate the final temperature of the water in the beaker. Okay. So in order to make it easy for ourselves, we're going to write ice here, and then we will write water here. For ice, we just figured that it has to go from minus 15 degrees Celsius ice to 0 degrees Celsius water. If we were to write this again, we have minus 15 degrees ice going to 0 degrees Celsius ice, and then it has to go to 0 degrees Celsius water, and now there is a certain temperature the water has reached, which we have to figure out. This is how it has to look like. Now, one important thing that we need to understand, when you write down all of this, I'm just gonna copy and write this here. Okay. So this is for ice. Now, another important thing that we have to add is, again, we will have to apply Q is equals to M into C into capital T, which we have to find. And as for the water, again, it has to be Q is equals to M into C into capital T. The reason why I have applied this, I have written this formula here as well as here, is because we know that the temperature of the water has to decrease from 28 to a certain temperature, which we have to find out, because when we add ice in water, the heat which is lost by ice is gained by water, because when we're doing this question, we have to assume that no heat is lost to the surroundings. So when no heat is lost to the surrounding, the heat has to be exchanged somewhere here. So if heat is lost by the water, it is gained by the ice. So this is how it has to work. The heat is still within the system. That is why we have written this formula here. So when we write 8,700, we're going to use this value, which is 8,700, plus we will have M, which is the mass of ice, which was given to us in the question above as 24 grams, 0.024 into the specific heat capacity, which is 20 specific heat capacity of water, because now that ice has converted into water, and now that water is going to increase by a certain temperature. So we have to take the specific heat capacity of water, which is 40 to 100, and you get 100.8 T. Now this is going to be equal to this, which is mass of water, which is given to us as 200 grams, that is 0.2 into 4200 MC, which which gives me 840 into delta T. Now what is delta T? That is a change in temperature. We know the temperature is 28 degrees Celsius and it's going to decrease by a certain temperature, so it has to be 28 minus T. Now when you solve this, you will have 8700 plus 100.8 T is equals to 840 into 28, which is 23520 minus 840 T. 840 T. Now you have to take the T terms to one side, and when you solve that, the value of T that you get is 15.7 degrees Celsius, which can be approximated to 16 degrees Celsius, and you will write the answer as 16 degrees Celsius. And this is it for the second part as well.